ultimately to be able to solve for x when we have a rational exponent. And you just have a couple of these to practice with for tonight. Filling in some blanks. Step 1, you have to isolate the base with the blank exponent. What do you think, Kristen? Yeah, very good. That goes up there. We can then eliminate that rational exponent by raising both sides to the reciprocal power. So here's how that's going to work. For instance, if your original exponent is 2/3, say that's the exponent in the problem, you're going to raise both sides to the reciprocal of 2/3. That would be the 3/2 power. Because watch what happens when you multiply reciprocals together. If you had 2/3 times 3/2, you get 6/6, which is 1. It makes that exponent go away. So that's the value in that multiplicative inverse. That's the value in the reciprocal, is that when you multiply the multiplicative inverse, or when you multiply inverses, I should say, you get 1, that multiplicative identity. So it's nice. Keep in mind, you want to simplify the resulting radical. You folks are learning that sometimes a plus or minus must appear in your answer. And it's in this step that I see the most errors. Sometimes students will just forget altogether that there may be more than one answer to the problem. So we do have to keep that in the back of our minds as we move through today's lesson. The last step, and this isn't just a step that I'm saying because I want you to be good students and I want you to practice your study skills and really want to get the right answer. I'm saying this because it could result in a wrong answer. You do have to check. You have to solve the resulting equation and then you do have to check your answers. That's not checking in the back of the book checking. That's checking in one of two ways. You could take your answer and plug it into the original equation, show me a little scratch work, and make sure it works. Or you could draw a picture of your graph that you get in your calculator. If the graph of the left side hits the graph of the right side in 2 spots, you get 2 answers. If the graph of the left side hits the graph of the right side in 1 spot, well then you only get 1 answer. So you could also just draw a real quick sketch of that scenario. Okay, let's do it. So step 1, or problem number 1 I should say, we have 9 times x to the 3/5 equals 72. Step 1 in the paragraph above, you have to isolate the base that has a rational exponent. There's only one base that has a rational exponent in this problem. 9 is not that base. 9 is raised to the 1st power. So that has its own little thing going on. X is raised to that rational exponent there. X is raised to the 3/5 power. So I have to isolate that base. I have to get x to the 3/5 by itself. So how do I do that? Go ahead, Alec. Yeah, divide both sides by 9. So we have x to the 3/5 equals 8. Now I want to get rid of that rational exponent. My goal is to get x by itself. If I want to get x by itself, the technique I'm teaching you today allows you to just raise both sides to the reciprocal power. So here's how that looks. See that 3/5 right there? I know that the reciprocal of 3/5 is 5/3. So I'm going to raise the left side to 5/3. And when I do the left side of the equal sign, I should also do to the right. Now that's super handy because I know that 3 times 5 is 15, and 5 times 3 is 15. Essentially what I get is x to the 15/15 power. In other words, I get x to the 1st. So I have to write that 1 there? No, so I got x by itself. So nice, right? Whew, x gone. Or I should say that little power of 1 there is gone. So 15/15 is just 1, and you don't have to write that power of 1. X to the 1st is the same as x. So that's the left side simplified. Now I have to simplify the right side. And what I'm thinking about here is what I know about my ER rule, my exponent over root. I know that this is the same thing as the cube root of 8 raised to the 5th power, based on my ER rule. Cube root of 8 is 2. 2 to the 5th is 32. So x in this problem is 32. We are not done. We have to check. So we take our answer of 32 and you plug it back into the original equation. You don't have to write me a book, but you have to show it. Some sort of check for every problem. If you skipped that part last night, because you're like, oh, she's just making me check for study skills purposes. No. Tonight, you can add that onto your assignment sheet. You should go back and check any equation that had you solving for x. Like I said, you don't have to write me a book. You just have to show a little bit of scratch work and check your answers. So x equals 32. You can go ahead and plug that back in. 32. If you plug that in for x, raise it to the 3/5 power. That's the same thing as taking the 5th root of 32, which is 2. And then you raise that to the 3rd power. 2 to the 3rd is 8. 8 times 9 is indeed 72. So this answer does work. Makes me pretty happy. Questions about that? So that's the process. Alec, what's up? I can't grade what's in your head. We're going to show our check, Alec. On to number 2, we have x minus 4 raised to the 2/3 power equals 25. So step 1, we want to isolate the base that has the rational exponent. Isolate the base that has the rational exponent. In this case, I see the base there is x minus 4, and it's isolated. There's nothing in front of it. There's nothing added onto it. It's all by itself. So step 1 is done for us in this problem. Step 2, I'm going to go ahead and get rid of that rational exponent. The idea here is to raise both sides to the 3/2 power. When I do this, this is so nice, right? 2 times 3 is 6. 3 times 2 is 6. 6 over 6, that's just 1. X minus 4 to the 1st power is just x minus 4, so that's good. So I simplified the left side. Now I'm going to simplify the right. I need to get rid of this for a second. Put my little thinking cloud here. So here's you thinking oh so carefully about what that right side of the equation means. I know that if I raise 25 to the 3/2 power, that is the same as taking the square root of both sides. When I square root both sides, and Miss Goldstein talked about this a few moments ago, what symbol should appear up there in that little thinking cloud? If you square root both sides, what do I need to think about? Yeah, plus or minus. Very good. So you want to kind of keep that in the back of your mind. When I square root both sides, I need the plus or minus symbol. When you have that 3/2 power, I'm square rooting. I need my plus or minus. And then this is raised to the 3rd power. So let's pretty that up down here a little bit. If I take the square root of 25, that's 5. And then 5 to the 3rd power, that's 125. So you have plus or minus 125. Okay. So now I'm almost done. I have x minus 4 equals 125, and x minus 4 equals negative 125. Add 4 onto both sides, that is 129. Add 4 over here, you get negative 121. So you'll see that, things in my way today. I'm going to go ahead and just throw it into my calculator to do a little check. I'll check 129 minus 4. Raise that to the 2/3 power. Remember your rational exponent, you have to put that in parentheses. Press enter. Woohoo! You get 25. How'd I do what? So I'm going to go ahead. I'll check negative 121 now, Luke, okay? So parentheses, negative 121 minus 4. and then that little caret there. My software, my calculator is a little newer, so it bounces it up. Some of the older calculators just leave it the same size as this. But either way you do it, you got to hit this up caret. Okay? I open up a set of parentheses so that my calculator doesn't make a hazardous mistake, especially if your calculator's a little older. And then I also get 25. So you can see that both of these numbers are solutions to the original equation, and neither of them were actually extraneous. What you got, Danielle? Do you have a question? Okay. I'm hoping that as a class, you're going to be able to give me that in a minute. Okay? So in this case, Alec, we got how many answers? How many did they get in number 1? Any ideas to what's different so far? Yeah, okay. So your eyes are going to the right spot. Yeah, something with that. You keep thinking. We're going to do a couple more, okay? All right. Number 3, we have 1/7 times the quantity of x plus 9 raised to the 3/2 power equals 49. Again, step 1, you isolate the base that has the rational exponent. So essentially what I need to get rid of right now is that 1/7. Any ideas? Good, Emily. Yeah, very good. Multiply both sides by 7, right? Jenna, is that what you were going to say? Yeah, nice job. All right. So that's how you isolate that base with a rational exponent. Okay, now I need to get rid of that 3/2 power. So I'm going to raise both sides to the 2/3. What you do to one side, you have to do to the other. So right now I have x plus 9 raised to the 6/6 power. 6/6, that's just 1. So it's kind of like that exponent on the left side went away. Over here in the back of my mind, I'm thinking like, oh, you know, this is the same thing right there as the cube root of 343 to the 2nd power. So I got to ask myself, do I need the plus or minus? Do I? When you cube root, do you need that? What do you think, Megan? No, very good. You can take the cube root of a negative, you get a negative. Cube root of a positive, you get a positive. So we don't need to think about that plus or minus case when, I think Alec was hinting around to it, when this number here is odd. So you cube root 343, is that 7? I think. 7 squared, 49. Subtract 9 from both sides, you get 40. You could check it in your calculator. Why don't you go ahead and practice your checking? And if you're good, you can go ahead on to number 4 around the room and observe with number 4. The answer is 256. I'm seeing people dropping their parentheses like in more than one spot. Like I saw a couple different papers as I walked around. Keep in mind that the quantity of 16x to the 3/4 is indeed a different number or value or expression than 16x to the 3/4. Those parentheses do have meaning. This is the same thing as 16 to the 3/4 times x to the 3/4. I actually just thought it was a little bit easier to keep the parentheses around the 16x, then get rid of that 3/4 first. I think some of you tried to apply your properties of exponents to that problem. You can do that, but I think it makes the problem a little bit longer. So you would raise 5/12 to the 4/3. That's the same thing as taking 8 to the 4th power. So you have 16x equals 4,096. Divide both sides by 16. You should get 256 for that answer. And it does work. Questions about that? Okay. You're good? Sorry, I thought I heard. No, it's okay. So the question we need to answer, and it's the question I really wanted you to think about throughout the entire course of the lesson. Sometimes we get one answer, sometimes we get more than one answer. Sometimes we need the plus or minus, and sometimes we don't. So we need to nail that down before I have you practice a couple more independent practice problems. So let's talk about that. When do we need the plus or minus? Noah? Even number in the radical, like where in the radical? Under the radicand. If the index is even, you need the plus or minus. That was well said, yes. If the index is even, you need the plus or minus. Okay, one more thing. Let's stretch it out a little bit. Let's take that a little bit of a step further. Is there a quick way you can look at the original rational exponent and determine right away if there's going to be a plus or minus in your work? I'm going to ask the question one more time because it's like the big question for today. If you look at the rational exponent at the beginning of the problem, is there a quick way to look at that number and determine that there's going to be more than one answer? Megan. Yeah, what has to be true about the numerator? It's even. Very good. Do you get that pattern? As we work through today's problems, when our numerator was even, you have to think about using plus or minus in your work. Does that make sense? It's really no different than when we did these problems before. If we had the quantity of x plus 2 squared equals 10, you had to square root both sides, right? Your exponent was even. 2 is like 2 over 1. The numerator was even. So it's really not different than what we did before. If your numerator is even, you need that plus or minus. And I think you had a question? Question? No? I just kind of talked about it. Okay. All right. Any other questions? So, Alec, does that help you with your question from before? Good. All right. So now, bam. Oh, I want you to try those independent practice problems on your own, and then I'll show you your answer. So, just before that bell rings, there they are. All of these solutions work. These do work. So I just wanted you to take a moment. The common mistake I saw more in this class than I had seen really all day is where that plus or minus goes. Some people are just tagging it at the very end. That is not where it goes. It actually goes up in where the radical is, so keep an eye out for that. And just a reminder, your book assignment is that guy there, highlighted there for you. So you take a look at that. Remember to go back and check if you haven't done so already.